Hello and good evening, Magnus Holberg here again behind the microphone. And now we're going to continue with part 2, looking at why and how the color is going up in our lakes and creeks. So let's look at part 2 and how it can look in a river when the color is increasing over the years. So how can it look? I've used some figures from the book Karlskrona Vattenverk 150 år or Karlskrona Waterworks 150 years. Here you can see figures from 1944 up to 2012. Now looking at about 70 in color in 44, then the color increased. And 82 you can see maybe around 125, something like that. And then we come to 2012 when we're going towards 200. And today you have seen peaks above 2, maybe up to 300. Most common treatment method today is flocculation and use of chemicals such as iron or aluminum. This will mean when you remove the flocks and create the sludge using sedimentation and sand filtration, and you can also use diffused air flotation in combination with sand filtration, but independently you will have more sludge, which will cost you more, and also, of course, a higher cost for chemicals. Now, in the case of Lyckebeon, you had very, very high color. And in that case, they have a pre-treatment in the old waterworks. And the pre-treatment is flocculation and using a continuous sand filter before pumping to the infiltration. After infiltration, they need to oxidate manganese and iron as a residue from the groundwater infiltration. Again, an extensive treatment, but it did do the trick, but it was very costly. Also, you can use ozone to break down the organic material and reduce the color. Then you also need granulated activated carbon. You might want to watch the video I did on ozone, which I talked about what you need and how a system could look using ozone. Also, you can use membranes. I talked about the pilot trial in Muscan in part 1 also. In this case, with color, you need nanofiltration, but you need to be careful with the pre-treatment and to look for concentrate handling, wash and flush intervals of the membranes. These are, of course, very important parameters in regard to operation and maintenance and costs. Also, you need more barriers for bacteria, chlorination, UV, UF. And of course, as I said in part 1, more bacteria, more high temperatures. You need to watch the need for barriers when you treat this water. Also, in some cases, you need to make an extension of an existing waterworks in order to get to the higher color numbers. Here I show you some pictures from a plant where I was involved in extending the ozone treatment because of higher color values. And when you extend an existing waterworks, you need to be careful in regard to not disturbing the production when you do the work, or you need to plan it very carefully so you can produce drinking water while you're rebuilding. Also, energy, operation and maintenance will be factors that can increase your cost depending on what method you choose. Also, and this is maybe a last resort, finding a new raw water source. And in this case, you have new investigations, you have permits you need to seek, you have maybe to build a new waterworks. That, as a case in the Karlskrona and Lyckebeon, they built the infiltration. And you also may need to look at extended piping network. Here are some pictures from a membrane plant and also from some drilling for looking at groundwater. Here are again some excellent pictures shot with my 90mm macro lens. With that, I will say thank you. Remember, water really rocks. Take good care and have a very good evening. Bye-bye.